So great evening guys. Today we're talking about one of the very important concept in physics, that is spring potential energy. So today we're talking about spring potential energy. So let's see guys here. This is a rubber band. So now I am applying the force. Let's see guys here. So what will happen? Let observe you people. So what will happen? Observe, observe, observe. Which means now I am taking a spring actually. Now I am taking a spring. So which is having a block of mass m in the block. So let's see guys here. Same thing I am doing here. So which means what guys here? So now, so object is here. Observe, observe guys, all of you observe. So now, so some force is acting on that. So it goes like this. So what you observe here? So previously, let us say, so this is the position here. So this is the position here. So there is a x displacement is happening. So x displacement is happen here. So in the x displacement is happen, force experience which directions? So force is moving in this direction. So that is minus F force is moving. So shall I go ahead with 0 to x displacement is happening. So this is the 0. From 0 to x displacement is happening. So actually we are covering, let's say assume 0 to x is happening. So let's see, observe you people. So what is the direction of this force and displacement? So minus F is directly proportional to x. So which means the force experience on this rubber is always opposite to the displacement. So displacement is opposite to the force. So which means I draw a BD diagram for this. So we draw a BD diagram, let us say M is the block here. So displacement is happened here. So force experience, F is the force experience in the direction. So displacement is happening in this direction. So the force and displacement we observe here, both are in opposite directions. So I am putting minus F and proportional to x. Both are anti-parallel. So anti-parallel means what the theta guys? Theta is 180 degrees. So both are anti-parallel. So theta is how much here? 180 degrees. That is the first thing we observe. Now I want to find out F value. I remove this proportionality. I put K here. So now finally what is the spring force? Spring force F is equal to Kx. Spring force F is equal to how much guys? How much force experience on this string? How to find out the spring force? Simple, as simple as that. So we have to find out the spring force by very simple, minus Kx. So minus Kx force. So where K stands what? Where K is equal to spring constant. Where K is equal to what here? Spring constant. So this is very important. Where K is equal to spring constant. So what are the units of K here? So K is equal to, so what you get guys here? K is equal to minus F by x. So this is Newton per meter. So what are the units of K? Spring constant. What are the units of spring constant? So the unit of spring constant K is equal to Newton per meter. So this is the unit of spring constant. Spring constant. And second thing is that I want to find out how much work done. I want to find out the work done did by this object. How much work done will did by this object. Let's say guys here now. So I want to calculate. So before that, in the text, I am taking a smaller part, let us say dx is the distance. So in this entire distance x, I am taking a very smaller part dx. So on this dx, the work done is dw. I hope it is clear, guys. So what is the work done here? What is the work done? So dw work done did here, dw work done. So dw work done did here, which is the displacement of dx and boundaries from 0 to x. So boundaries from 0 to x, and I want to find out dw. So what is the formula, guys? dw everybody knows. So in lower class you learn about dw is equal to f into, what is the displacement here, guys? Dx is the displacement into cos theta. So I hope you people are understanding. So f into dx into cos theta, work done formula. So dw is equal to, so f into dx into cos theta, guys. Theta how much? Anti-parallel. So theta is equal to how much here? Cos 180. So cos 180 how much you get? That is minus 1. Cos 180 plus 0. Cos 180 plus 0 means what? Third quadrant. All silver T. Tan is only the positive. So I put minus 1. Cos 0 means how much? 1. We put minus 1 based upon the quadrant which lies. So finally what, guys, here? Minus f into dx. So dw is equal to what you get? dw is equal to minus f into dx. Now what I have to do is that I have to substitute f value. So what is the f value? Just now we find out. So dw is equal to minus kx into dx. Minus kx into dx. So what I have to get here? Minus of minus what? Plus. So kx into dx. dw. So dw is equal to how much you get? Kx into dx. Integral applied, integration on both sides. Now we have to apply the integration on both sides. So I am applying integration on both sides. So now what will happen? Now I am applying integration on both sides. Now what will happen? So integral of dw is equal to integral of 0 to x. So the limit slides from 0 to x. So when limit slides from 0 to x, so what is that one? Kx dx. So kx dx. So k is the constant taken outside. Integral of 0 to x into x dx. So what you get? We apply integration rules. What you have to get? X power n by n, x power n plus 1 by n plus 1. We know this one. Integral of x power n. What is the formula? X power n plus 1 by n plus 1. According to that, can you see how much, guys? 1. 1 plus 1 by 1 plus 1. So finally what you have to get? Of kx square. So of kx square is the formula for spring potential energy. Spring potential energy, what is the formula, guys? Of kx square. So let's see, guys, now we have to take an example. Let's say an example. We have to find out. Let us say same object of spring constant 0.8 Newton per meter. Observe that 0.8 Newton per meter, and displacement is happening that 1 centimeter. 1 centimeter displacement is happening. So now I want to find out spring potential energy. W is equal to half kx square. So half into, what is the k, guys? 0.8. What is the x value with that? 1 into 10 power minus 2 whole square. So half into 0.8 into 10 power minus 4. So 2 1 there, 2 0.4. So what you get? 4 into 10 power minus 5. Simple 0. What do you call it? Should I go with 10 by 10? No issue, I hope. 10 by 10. So 0.4 into 10. This is the joule. So what is the value, guys, here? 4 into 10 power minus 5 joules you have to get. Thank you.